definition of increasing function according to most analysis book is this. F is increasing on A and B, between A and B, right? If that makes sense to you? What does that mean? Right? For all how do I want to say it? I'll just say that much. For all A less than B, but I already wrote that down. I'm going to draw the picture for you. Suppose we have a function here. This is A right here, and that's f of A. And this is B right here, and this is f of B. And then function is like somewhat like that. You know what I'm saying? Okay, so this is the definition of increasing function, and it makes sense, right? Except this is not exactly the definition of increasing function. Real definition of increasing function, for some stupid reason, has an equal sign there. What? Why? And that equal sign makes a huge difference. Notice that there's no equal sign here, right? Okay, let's just think about this. So in case function looks like this, that part is flat. Let's say this is A, and that point is B, and then let's say that point is C. Then if this is flat right here, is this thing increasing at C or not? Right, according to this definition, it is. F is increasing at x is equal to C, according to this definition. You know what I'm saying? But f prime of C is equal to 0. Now, common sense would tell you that you should take that point out, right? Nope, you don't. They purposely wanted to include this, and there is a reason for it, which I don't want to get into. It has to do with analysis, and it's a big headache. Okay, then I'm going to give you there are two more funny examples, and they are both, it gets worse. Okay, let's think about this case then. Suppose we have this. So this point is A, like before, this point is B, and let's say that point is C, right? Then you would say f is decreasing, right? On and f is increasing on. Now there's a problem with this. Do you see the problem by putting the bracket? That means f is increasing and decreasing. F is increasing and decreasing at the same time at x is equal to C. You know what I'm saying? Because there's an equal sign. That's what the significance of this equal sign is. So it is increasing here and decreasing at C at the same time. I mean, I would exclude that point and make it just neither increasing nor decreasing. That makes sense because it's flat, right? It's not changing up or down. But no, they want to include it in both places. What? The whole point is the increasing decreasingness is not defined by derivative at all. And this is the worst way, the worst example. I'm going to have to draw the coordinate. So let's draw the coordinate here. Suppose we have a constant function. You see where this is going, right? So f is constant. Like f of x is equal to c. And this is c right here. Good. In this case, is f increasing everywhere? Say this is A, this is B, right? Let's check with our definition. So A is less than B, right? And then question is f of A less than or equal to f of B? Yep. Answer is yes, right? Which means f is increasing. Everywhere. But then do you see f is decreasing then? What? This function is increasing and decreasing everywhere? What is wrong with mathematicians, right? I mean, by now you have to wonder, who the hell defines increasing and decreasing that way? Everybody. And this, math teachers had a meeting on this. So I ended up asking 2 different professors about this. One professor said, there's an equal sign? No, you're kidding, right? I mean, that got his reaction, like, why the hell would I be an equal? This is a professor. Why would there be an equal sign? That makes no sense. I did not know there should be an equal sign. So that's one reaction. And the other reaction is, well, that's why I asked that guy, but that's like not an analyst, right? So I finally asked the analyst, right? Who does this? And these are the people. And then he said, well, increasing really means not decreasing in this sense. What? I know that reaction just says it all, right? And of course, decreasing means not increasing. Now, why would anybody want to do such a thing? What's the motivation for it? Because this is kind of my definition, and then I found the loophole, okay? My definition. My way. My definition is, you see, different professors, different instructors have different definition, okay? You can totally do this on my test. And I'm going to show you why you can get away with this on AP as well. Okay? Watch this. Suppose we have a function. I'm going to throw it. I'm going to make this axis black. And then go back to red. Suppose we have this function. Let's just. So this is A. This is B as usual. And let's call this point C. And let's call this point D. So we want our C to be the location of maximum and D to be the location of minimum. Okay? Remember my format, and this is why this format is critical and it has to be written this way. F prime of X is positive, because you don't want to say this now, right? Greater than or equal to, God no. is strictly positive. I'm defining this with a derivative, and in analysis, there is a little bit of problem with this. That's why they go with that weird definition. I kind of looked into it, and I don't want to get into it now. And then you notice I put this in parentheses. That means increasing on, and then I put the A to C union, and then I put D to B. Let's just think about this for a second. What do I mean by this? I am not saying function is increasing in this interval, because if I want to say function is increasing in this interval, I have to make this thing's bracket, and we go back into the same problem, right? I'm not saying that at all. All I'm saying is the derivative is positive in this. That's all I'm saying. And in parentheses, meaning while derivative is positive, function happens to be increasing there because derivative is positive. See, converse is not necessarily true, right? So if derivative is positive, this direction, am I doing this right? Oh, yeah, I am. Derivative is positive, that means function is increasing. But function is increasing does not necessarily mean positive derivative according to that idiotic definition of increasing function. You know what I'm saying? So all I'm saying is derivative is positive on this interval, and that happens to be increasing within it. That's all I'm saying. This is a loophole I found. You can totally get away with this on AP if you keep doing it this way. And also f prime of x is negative, and while it's negative, it's definitely decreasing, right? On parenthesis C comma D. Right? Now, therefore, we can say max f of C, right? And min f of D. This is my way. And it's critical you do it this way in order to get away from this idiotic definition. Now, so on your book, they always put the brackets, right? Because they want to say function is increasing, and then according to the definition, this needs to be bracket. So I want to get away with all that. But at the same time, if the AP asks you particle motion, where's the velocity positive? When is the particle moving to the positive side? Then it has to be parenthesis, not bracket. So like when to do what? This is just so confusing. So I had to find the uniform way to answer this, and you will always ignore the question and answer it. Actually, they don't penalize you for not using bracket, but we'll say it this way. Derivative is positive, and that's definitely parenthesis only, and that's it. You know what I'm saying? Yeah, that's the loophole I found. Yeah, question, Sarah. You're muted. No question? Yeah, I saw a hand.
Oh, sorry. I was on mute.
Okay.
Yeah, I was asking, like, in this case, do we need to like calculate the values of H in A and B to see if they are larger or smaller than max or min?
Oh yeah, actually, yeah. I'm gonna amend this. Yes, excellent question. Endpoint always comes into play, right? Because look at it. Is that the minimum locally? Yeah. So this, I'm gonna add one more here. This f of a is a minimum, right? Because it's left endpoint. I'm so glad that you brought this up. And do you see that's a maximum because it's higher than any nearby points here? So this is f of d, f of b. Let's just throw those in. Whenever I ask you max or min, local or absolute, endpoint always comes into play. Endpoint is either min or max. It has to be always included. You cannot have an endpoint without this thing being extrema. How's that? Good? So it's like, this is the most common mistake, and students neglect this and lose a lot of points. No, you have to include endpoint, always. It's gotta be one or the other. Any other
So
question before?
endpoints are always local max and mins, but they can also
Yeah,
be the entire max also.
it could be absolute. Yeah, see, in this case,
Okay.
that's your absolute max, isn't it? Right, so
Uh-huh.
endpoint always has to be either local, at least, min, or local max. Always. Question? I think this puts everything to bed, and now you understand my motivation of enforcing this, right? If you write it in any other way, that's mathematically incorrect statement, right? This is the only way you can get away with it. That way you don't have to worry about is when is it bracket? It's never for our purpose. It's always parenthesis, but you have to word it very carefully. Good? Okay, then we'll do some problems now, such as 23. And of course, in 23, we are pretending we cannot see this function, right? We have to rely on derivative alone, right? Okay, so let's do it. So that's 23. Should we take a derivative first? Yeah, let's do that. I'm going to zoom in a little bit. So f prime of x is equal to u, product rule, right? The first one is u, so 1 times 4 minus x to the 1/2 power plus x, and then 1/2 parenthesis negative 1/2 power a. You with me? And you write 4 minus x. Okay, your job now to find the mistake I made here. What's the mistake? This is common mistake.
Times -1.
Times -1, right? The chain rule comes into play, right? This thingy. That's very common. Now, this thing is kind of headache to work like this, so I always like to find the common denominator and combine it. Common denominator is this. Agree? Say yes. Okay. And the numerator then happens to be 4 minus x here, minus x over 2a. Say yes.
Yes.
Okay, I made this line ridiculously long. Okay, so what we have is 4 minus 3 over 2x over square root 4 minus x. Okay, the reason this is easier to work with than the previous line is you notice that denominator is always positive. So you only need to worry about the numerator. You know what I'm saying? Okay, now critical points. Critical points are, we want to look at the denominator first, right? Undefined, x is equal to 4. But, look at the domain. This is the endpoint. This thing ends right here and it doesn't exist, right? So this critical points, what the reason it doesn't exist is because it gets vertical, it's infinity. You know what I'm saying? And this thing extends to the other side, whatever. Okay, so we should remind ourselves we are not going to evaluate anything beyond 4. The function doesn't exist there, okay? And the other one, of course, is whatever makes this thing 0, right? Is x equal to 8 over 3? Too much algebra? I mean, you don't have to show any algebra work for me. You just need to show calculus work. I'm going to assume you know how to do algebra if it's correct. If it's not correct, there's no partial credit anyway. You with me? Okay, well then. Shall we evaluate this? This is easy enough to figure out where this is positive and where this is negative, right? We don't have to throw that little chart because this is always positive. So we only need to look at this, and that's a linear function now, isn't it? So let's say f of x is positive. Remember this? Increasing loophole. This is increasing on. Now, Is it just on 8 over 3 to 4? And that's it? You're making this thing positive. You're setting this to be positive. You get it? Okay, and f prime of x is negative. That means it's decreasing right there on, and this one you can put negative infinity to 8 over 3.
Isn't
So
it the
far,
other way around?
did I put it backward? Yes, I did. Oh my God.
Because dividing by
Yesterday I
negative.
put up one thing backward. Have you noticed it? Thank you. This way and then 4. So far so good. Notice that I'm always using parentheses on both ends. Okay, so we can say therefore we have max at f of, what is it, 8 over 3. How about that? What is, can somebody plug in 8 over 3 to this and tell, oh, I just copied from the notes. 16 over 3 root 3. Max min is always a y value, okay? Now, what did I forget now? What do you mean? This is perfect. What did I forget? I forgot one thing. Your job to catch it. So we can see that's your max, right? That's definitely max.
Endpoints.
Yeah, this is your minimum by looking at the graph, right? Oh, sneaky. You see how easily it could be forgotten? Min at f of 4. That's local, but still, nevertheless, you have to include that. Now it's complete. How about that? Are we good?
Sorry, wait. How are you supposed to know that without the graph?
No, you have to know this. Oh, okay, let's think about it. Let's just think about this part. Seeing from 8 over 3 to 4, right? So you just draw abstract graph. It ends right there. You know what I'm saying? See, this is 8 over 3. And this is 4.
Okay, that makes sense.
Right? So you have to really at least do a rough sketch. And this end goes down. We don't know exactly what it looks like, but it has to look somewhat like that. You know what I'm saying? Right. So don't try to analyze this thing to this. You remember how analysts are with that definition and all? Those are the people who gave us that definition. I'm pretty sure when Newton came up with this, that's not how he defined it, but they changed the definition along the way. I'm pretty sure. Sasha, do you have a question?
So if you have a square root on the bottom, you can also write it as like to the negative 1/2. So if it equals 0, like, because you can put it on the numerator.
Wait, you're breaking up. Repeat the question one more time.
So if you have a square root function on the bottom, you can
Uh-huh.
put it in the numerator. So if you make it equal to 0, does that mean the derivative doesn't exist, or can it be 0?
If the numerator becomes 0, then it's 0, then it's flat right there.
But you could write the square root function in the numerator or the denominator.
Oh, no, this one is definitely in the denominator. Okay, whenever you have a negative exponent, that is in the denominator, even if you like that. Right? Rule of exponent thing, right? Okay. Any other question before I move on to 24? 24 is even weirder looking one, right? Okay. This one, instead of using product rule, because I really load product rule, I'm going to do it this way. Is it x to the 4/3 power plus 8x to the 1/3 power 8? Oh yeah, that's clever now, isn't it? Yeah, why would you do all that work? God, product rule is awful. So that way, g prime of x is 4/3 x to the 1/3 power plus now 8 over 3 and x to the negative 2/3 power. So far with me? how are you going to evaluate points? Is it positive, negative, and right? Here's a trick. Watch this. What I want to do is factor 4/3. That makes sense, right? You see 4/3 here and 4/3 there. And then I'm going to factor this. What? Now tell me what's left in the parentheses. I'll do the second one. There's 2, right? Okay, what do you have for the first one? X to something power. If you distribute it, what is it?
Is it 1?
It's 1, right? This is 1. Oh my God. That is clever, isn't it? Why is it clever? Because you notice this is always positive. This is x to the 1/3, well, in the denominator square, right? So we only need to care about this thingy, eh? Right. Okay, let me rewrite it. Okay, it's 4 times x plus 2 over, let me write it this way, cube root of, can you even see this thing? Cube root of x quantity squared. Is it better if I write it like that? Now you can see the denominator is always positive, eh?
Yeah.
Oh my God, that was very clever now, wasn't it? Okay, now we move on to critical point.
Wait, is there a 3 also?
Where's the 3?
In the denominator?
Cube root. Oh, 3. Oh, that 3. Yeah, thanks. That 3. Okay. So now critical points. I'm so glad that Miss Lattery actually called it critical points because it's a seamless transition now. Okay, critical points when denominator is equal to 0, this. And from the graph you see it's vertical, right? Vertical tangents, that's why it doesn't exist. You get it? I mean, even if you're not graphing this, because there's no vertical thingy, it exists everywhere originally, this function. And now it becomes vertical asymptote here. That means it's a vertical tangent. You get it? Yeah, okay. Infinity, if you will. And then also x is equal to -2. This is flat. That's right here. You know what I'm saying? Okay. Now, then we can say f prime of x is positive, meaning increasing, on, is it from, now we have to be careful, we still have to take 0 out, so we'll say -2 to 0 union with 0 and infinity, like that, eh? Because you have to be consistent, you cannot have it both ways. Oh, that's increasing everywhere. No, it's not. That's like derivative doesn't exist. I cannot claim it's positive where it doesn't exist. You know what I'm saying? You gotta exist to be positive. So that's a little byproduct of my loophole. Okay, and f prime of x is negative, which means decreasing right there on -infinity to -2. You with me? So therefore, we have minimum at, did I call it f? This is g. G prime. Okay, minimum at g of -2. And just looking it up, is this.
So are all the places where the derivative doesn't exist excluded from increasing,
yeah.
decreasing?
Yeah.
Okay.
Oh, no, it's not increasing, decreasing. It could be still increasing according to that idiotic definition. I'm not saying it's increasing. I'm just saying derivative is positive or negative. So we have to exclude it, because if it doesn't exist, it cannot be positive or negative. You get it? That's the price we pay for using this loophole. Okay, Ethan, do you have a question?
Yeah, is it like the absolute minimum in this case?
This case is absolute min.
Okay, thank you.
Right? You want me to write it in? It depends on what the question is. Do they say absolute? Do we have to specify this?
Just local extrema.
Oh, okay.
But
So
I remember you writing absolute for a few ones.
While we are at it, this happens to be absolute. Good. Okay, any other question before I move on to 25 now? How are we doing on time? Okay, 5 minutes left. Okay. We are a little bit on a time crunch here. Okay. Okay, 25, something new. Oh, can we feel this? Can we feel this first? Let's feel it together, shall we? I'm gonna put it on the grapher. I'm gonna put that denominator without the numerator, okay? Where is my graphing thingy? Show up. This computer is so slow. It's not showing up. See, it's loading. Uh-oh. Watch this thing crash now. Okay. Oh, there are 2 of them. And it says not responding. Oh, no. Okay. Okay, loaded without a problem. Okay. I'm going to put this denominator thing only, and then I want you to be able to feel it. Do you see Gaussian looking thing? 1 over open parenthesis x to the 4th plus 4. I'm going to rescale it. Do you see Gaussian looking thingy?
We can't see the graph.
You cannot? Wait, I think I
Oh,
screwed.
now we can. Sorry.
Yeah, I typed square. See, Gaussian looking thingy, right? Now we are going to multiply this by this, right? Negative x, which is totally an odd function. What happens? Can you predict how this is going to look? This side, positive times positive, so it's going to go up and then go down to 0 because it's multiplying 0 times whatever that number is, which is 1/4. And this time, this side will be negative, so it will be like that. Do you feel it? I'm going to copy and paste that. I'm going to superimpose everything so you can all feel it. This, I'm going to put this. Ready? Bang. How about that? Amazing, isn't it? Do you feel it? Okay, I'm gonna get rid of these 2. This is our function. Okay, I'm gonna copy this. Oh, 2 minutes left in the class. This is real-time cruncher. Course is huge. God. To do this and record everything in real time live is not as easy as it looks, trust me. Okay. Looks like we'll do this and then have to call it a day, and hopefully other class will ask exactly the same question. Okay. Quotient rule, right? You suck it up and do it, right? So h prime of x is equal to the denominator square numerator u prime -1 times x squared plus 4 minus negative x plus x. You see that? And then derivative, which is 2x. You with me? So we have negative x squared, 2x squared. So we have x squared minus 4 over x squared plus 4 squared, which is also known as x minus 2. Let's put plus first, x minus 2 here. Too much algebra? And once again, denominator is always positive, right? That common denominator theme is pretty good. So that numerator alone is our parabola now, isn't it? So it's negative right here, is positive here, right? That was quick. So we can say h prime of x is positive, meaning increasing on negative infinity. Oh, by the way, why am I neglecting where this is critical points? Actually, I think I'm going to write down the critical points. I'm not neglecting. Do you notice that denominator is never equal to 0?
Is it because it's imaginary?
Yeah, it's imaginary if you set it equal to 0 now, isn't it? Yeah, so this time I didn't forget. I'm still writing down critical points. Critical points is x is equal to plus or minus 2, and that's it. You know what I'm saying? So it's increasing at negative infinity up to negative 2, union that with 2 and infinity, and that our graph confirms it, right? Yeah. And then f h prime of x negative, meaning it's decreasing on in between negative 2 to 2. So now we can say, therefore, max at h of negative 2. What do we get? Somebody calculate negative 2 in there for me. And then max min.
I think it's 1/4.
H of 2. So this is 1/4. And this, of course, is the negative 1/4, isn't it? Huh.